Can you see the screen?
Yes, sir.
Okay, right. So now what we can do is we can solve what you can see now. Can you see the problem in the draw in the paper?
Yes, sir.
We can see.
Okay, right. There is nothing obstructing, right? Obstructing the paper, no? Okay, right. So I'll show you how to solve this problem using superposition theorem, right? So simply what superposition theorem says is actually, right? So for example, just assume that you are asked to calculate the current through this 2 ohm resistor, right? So you have to calculate the current through this 2 ohm resistor using superposition theorem. So what superposition theorem says is, if you calculate the current through this 2 ohm resistance without this 7 ohm resistor, right, you have to short circuit or you have to replace this 7 voltage battery with its internal resistance, right? If it does not have any internal resistance, just simply short circuit it and then calculate the current. So just assume if you short circuit this one and you have calculated, if you short circuit this battery and calculated the current through this one is I1, and if you short circuit this one and with this battery you have to calculate the current I2, right? Hence what the superposition theorem states is the actual current through the resistance when these two batteries are active is equal to the addition of I1 and I2, right? Most of you have missed this step in the in-course exams. Of course, I think more than half of you have done it correctly, but I just want to make it clear. Right now, okay, I'll explain in detail, right? So a circuit, 28 voltage battery, 4 ohm resistor, 2 ohm resistor, 1 ohm resistor, and a 7 voltage battery, right? Let's see how we can solve this one using superposition theorem, right? Okay, first step, we'll short circuit this 7 voltage battery, right? Hence the circuit can be redrawn something like this, right? So here 28 voltage, 2 ohm and 1 ohm resistance. This will be short circuit, am I right? 4 ohm, right? First we'll calculate I1, right, which means this is your I1, right? So now if this is short circuited, of course we can see that the 28 voltage battery is connected between this 4 ohm resistor and which is connected in series with this 1 ohm parallel 2 ohm, am I right? Right, this 4 ohm resistor is connected in series with, right, just assume this is here, so I can see that this 2 ohm and 1 ohm is parallel, right? So 2 ohm parallel 1 ohm becomes, so the equivalent resistance will be 1.2 over 1 plus 2, which is 2 over 3 ohms, am I right? Now calculate the calculate the current through the whole circuit, right? So the equivalent, so the total resistance will be 4 plus 2 over 3 ohms, am I right? And then the current through the resistance, let this be I equals V over R, am I right? 28 over 4 plus 2/3, am I right? Now, yeah, 4 into 3, 12 plus 2, 14 over 3, right? So this becomes 28 over 14, that 3 will be on top. All right, so simply this will be 2, so equals 6, amperes. Right, so the current flowing through the circuit without this battery is 6 amperes. Now that 6 ampere is going to divide into two branches at this point, am I right? through this 2 ohm resistor and this 1 ohm resistor, which means this 6 ampere resistance will be proportionally divided between this one, right, which is the higher resistance will be low current, right? So 2:1, right? So I can write that you will have 4 amperes current through this one and 2 amperes current through this 2 ohm resistance. Am I right? 2 amperes current through this 2 ohm resistor. Okay, so now we have calculated that if you have done the analysis without this 7-volt battery, you have calculated that you can have a 2 ampere current which is flowing from top to bottom through this 2 ohm resistor. Okay, now we'll see what will happen if we short circuit this 28 voltage battery, right? So I'll draw the circuit diagram. So 4 ohm resistor, 2 ohm resistor, and 1 ohm resistor. And here will be the 7 voltage battery, and this time the other side is short circuited. Am I right? Now you are going to have a current, let's see, I dash, right? I don't want to confuse, right? Here I have used I, so this be I dash, right? So this I is equal to, right, 7 over 1 ohm plus this 4 parallel 2. Am I right? So 4 parallel 2 becomes 4.2 over 4 plus 2, which is 8 over 6. Am I right? So 4 over 3. Right? Now substitute that one. So the total resistance will be 1 plus 4 over 3 ohms. Right? Then I dash can be written as 7 voltage over 1 plus 4 over 3. Am I right? So 4 over 3, I can write 3. So this one can be written as 7 over 4 plus 3 will be 7. That 3 will go on top, right? So 7 and 7 will get cancelled. So you can calculate the I dash as 3 amperes. Now that 3 ampere is going to divide among these two branches, right, which in the ratio of 1 is to here 2, right? So 3 amperes 1:2 means in this branch you will have 1 ampere, and this branch you will have 2 amperes. Am I right? Total of 3 amperes. Now you have calculated the current through the 2 ohm resistors with the 28 voltage battery and the 7 voltage battery. Right now the actual current through the 2 ohm resistance I 2 ohm will be, see here, at this case you have the current of 2 amperes which is flowing from top to bottom, and here also you have another 2 ampere current which is flowing from top to bottom. So altogether the current through the 2 ohm resistance will be 2 plus 2 equals 4 amperes, and the direction is from top to bottom. Clear, right? So this is actually the superposition theorem, right? What you are doing is you are short circuiting a battery first, right? You are short circuiting the battery first, and then you are doing the analysis. You are using your Kirchhoff's current law and Ohm's law to Kirchhoff's current law, voltage law, and Ohm's law to calculate the current through the branch, the particular branch, and then you are doing the same analysis with the other resistance short circuited, right? With the other battery short circuited, and then you have to do the analysis, and finally you have to add both together, right? For example, if you have the same 2 amperes current in the other way around, right? If the battery is connected in the other way around, your resultant will be 2 minus 2, and you will have effectively no current flowing to the 2 ampere resistance, right? So this is the arithmetic sum, right? The direction is really important, right? You have to consider whether it is the current is flowing from top to bottom or bottom to top, right? If they are in the same direction, just add them together, put the answer. If they are in the opposite direction, put the difference with the direction as the maximum current's direction, right? So this is how solving your superposition theorem, right? Any doubts? I have corrected your in-course papers,
No,
and
sir.
most of you have almost about half of you have stopped with the first step. You didn't go for the last step, right? That's why I decided to repeat that one. I don't want to waste the time, so I recorded the lectures and then I am repeating it. Okay. So any doubts or any questions on superposition theorem?
No, sir.
Okay, clear.
Clear, sir.
Right. Now I would advise you to go and do the tutorial question, right? I have given you one. Yeah, I think there is a tutorial. There are about one or two, I don't know, but try to solve the questions, right? Now I'll solve another example on Thevenin's theorem, right? This one also. Okay, right? So I'll give you a circuit. The same circuit, kind of. Right, so this be 12 ohm, and this is 4 ohm, this is 8 ohm, and this is 5 ohm with the battery of 48 voltage. Right, now the question is calculate the current through the 5 ohm resistor using Thevenin's theorem. Right, find the VTH. Okay, right, find, okay, let this be A and B. I'll give the question in detail, right? So find VTH, RTH, and current through 5 ohm resistor, right? RTH across A and B. Right, so this is the question. Now what Thevenin's theorem says is, right, you can draw any complicated circuit into a simplified circuit with an equivalent battery and a single resistance, but the circuit must have only linear elements, which means you must have only resistors in your circuits and batteries, right? If there are any non-linear elements, then you cannot apply Norton's or Thevenin's theorem, right? Right, okay, now the question is across A and B, right? The first step is to remove the 5 ohm resistor, right? So now you will have a circuit something like this. Right, so this is your 48 voltage, 12 ohm resistor, 8 ohm resistor, 4 ohm resistor, A and B, right? So this is the first step, right? And then what now you have to do is you have to calculate VTH, right? VTH is actually the voltage across A and B. VTH is actually the voltage across A and B. Now you need to calculate the voltage across A and B. How can you calculate the voltage across A and B? Right? If this is open circuited, is there any current through this 8 ohm resistor? No, right? Because since the A and B is open circuited, this will be simply, right, a floating resistor. There will not be any current flowing through the resistor, right? So here, this 48 voltage is divided between this 12 ohm resistor and this 4 ohm resistor, right? So if I simply say, right, so the 48 voltage is divided 3:1, am I right? In the ratio of 3:1. 48 means the voltage across 12 ohm resistor will be 36 voltage, and the voltage across the 4 ohm resistor will be 12 voltage. Am I right? Or if it is difficult, let's take the current I. Right? You don't know what I is, but since this is floating, 48, right, 12 and 4, it is 16, right? So I equals 48 over 16, am I right? Equals 3 amperes, right? If it is 3 amperes, then VAB is equal to V across this 4 voltage resistance, because the current through 8 ohm resistor is 0. Hence, IR becomes 0. So, I into this 4 ohm resistor will be your VTH, right? I is 3 amperes, 4 ohm resistance. So, altogether, your VTH will be 12 voltage. Am I right? Okay. Now you have done one, right? You have done the first part. Now you have to calculate the RTH, right? To calculate RTH, what you have to do is, again, you have to short circuit the battery, or you have to replace the battery with its internal resistance, right? If the battery does not have any internal resistance, just simply short circuit it, right? So your circuit will be something like this, right? There is no internal resistance given, so no need to worry about it, right? This is your 12 ohm resistors, 4 ohm resistor, and this is short circuited here, 8, 4, this is your A and B, right? And your RTH is actually the resistance. When you are looking from the A and B, the total resistance offered by the circuit will be your RTH, right? This is your RTH. You are looking from here, and the total resistance offered by the circuit will be your RTH, right? So what is the resistance offered when you are looking from the point A and B, right? So across this one, you can see that 12 and 4 are connected in parallel, which is connected in this with this 8 ohm resistor in series. Am I right? So 12 and parallel, you can write it as, yeah. So 12.4 over 12 plus 4. Am I right? 48 over 16, which is 3 ohms. Am I right? 3 ohms, right? Hence, your RTH will be 8 ohms plus this 3 ohm, right? Which is 11 ohms. Clear? Right now, you have calculated VTH and you have calculated the RTH. You have to draw the equivalent circuit, right? Remember, this is the crucial step in Thevenin's theorem, right? You have to draw the equivalent circuit. What Thevenin's theorem states is, right? So any circuit can be replaced with a circuit which has VTH as the single or sole battery and RTH as the sole resistance across A and B. Right now, look at here. What is the resistance you have across A and B? Which is 5 ohm, right? Now, if you want to calculate the current through the 5 ohm resistor, connect that 5 ohm resistor here, and you know what is RTH is actually 11 ohm resistor, and VTH is 12 voltage. Am I right? Your VTH is 12 voltage, RTH is 11, this is 5. So the current through this one, I, right? So I equals, since this is a single loop, I equals VTH over RTH plus this R. Am I right? So VTH is 12 over 11 plus 5, 16 amperes, which you can simply write it as 3 over 4 or 0.75 amperes. Clear, right? So when you are asked to solve a circuit using Thevenin's theorem, remember these 3 steps are crucial. First of all, you have to calculate the VTH, and then you have to calculate the RTH, and finally you have to draw the equivalent circuit with VTH, RTH, and the removed resistor R. And then if you apply simply Ohm's law, you will get the final answer. Clear? Any questions?
No, sir, it's clear.
Any doubts?
No, sir.
No, sir.
Right. So now I ask you to try the in-course questions, right? Do you have the in-course exam papers? Anybody? Can you share the in-course exam papers so that I can upload it in Google Classroom? Right now, all of you just practice the question using the method what I have discussed here. Okay, right? And if you faced any problems, or if you have any problems, just let me know, right? Because you have to answer one question, right? The one whole question will be from your electricity section. You all know that, right? Okay, right? So yeah, I think I have recorded this session as well, right? So